This video is about how to construct a unit circle. First of all, let's look at in a circle. What's the coordinate for x and y? We have this right triangle. For angle theta, we know opposite side will be y, and adjacent side will be x. Hypotenuse will be this arm. According to the SOHCAHTOA, we know that sine theta equals y over r. For cosine theta equals x over r. Then we solve for x and y. Do cross multiply. We got x equals r times cosine. For y, we do cross multiply. We got y equals r times sine theta. Therefore, let me write down over here, x equals r times cosine theta. Y equals r times sine theta. This will be the coordinate for any point in a circle. What's a unit circle? Unit circle means any circle whose radius equals 1. Suppose this is a unit circle. We know radius equals 1. Therefore, we plug in here, we got cosine theta, and y equals sine theta. In other words, for a unit circle, r equals 1, then we have coordinate xy will be cosine theta and sine theta. This is a very important fact when you construct a unit circle. So let me write down here. Any point on a unit circle, the coordinates will be cosine theta and sine theta. First of all, we will use the different color to connect this line. For the red line on the first quadrant, we label as 30 degree. And for green one, that's 45 degree. Then for the blue one, it will be 60 degree. This will be 0 degree. Here's 90 degree. We call any angle for the first quadrant. We know this is the first quadrant, second, third, and a fourth quadrant. For the first quadrant angle, we know the angle will be between 0 degree to 90 degree. We call this is a reference angle. Normally we use theta prime to show that. In other words, any angle in the first quadrant we call reference angle, so it will be equals theta prime. For second quadrant, we can use reference angle to show any angle in the second quadrant. It will be theta equals 180 minus the reference angle. For third quadrant, we can use theta equals 180 plus theta prime, means the reference angle. For fourth quadrant, angle will be 360 minus the reference angle. We know that this x-axis, this will be 0 degree. This is 90 degree, 180 degree, 270 degree, and also we have 360 degree. So for second quadrant angle, we can use 180 minus your reference angle. Then the third quadrant, we use 180 plus reference angle. Then for the fourth quadrant angle, we use 360 minus reference angle. Now you can count 0, 30, 45, 60, and 90 degree as a reference angle. So for the second quadrant, you got to do this calculation. For red line, that means the reference angle will be 30 degree. So for second quadrant, I use 180 minus reference angle, means 180 minus 30, I got for third quadrant, we know that's 180 plus reference angle, means 180 plus 30 degree, that's 210 degree. For the fourth quadrant, we use 360 degree minus reference angle. 360 minus 30, you will get 330 degree. Now let's go to green line. Green line, that's 45 degree. So use 180 minus 45 for the second quadrant angle. That will be 135 degree. For third quadrant, we got 180 plus 45, that's 225 degree. For fourth quadrant, we got the 360 minus 45, that's 315 degree. Now let's go to 60. For the 60 degree as reference angle, then for the second quadrant, you will get 120 degree. For the third quadrant, 180 plus 60 got 240 degree. For fourth quadrant, use 360 minus 60, that's 300 degree. Let's look at the angle fall on the x-axis and the y-axis. We already know that this will be 180 degree. Here's a 270 degree and a 360 degree. When you do this, remember the same color line, they have the same reference angle. So let's go to radian now. For 30, we know that's pi over 6. For 45, that's pi over 4. For 60, that will be pi over 3. 90 will be pi over 2. And 0 still 0. For 360, that's 2 pi. For 180 will be pi. And 270 will be 3 pi over 2. Let's talk about for angles in quadrant 2, 3, 4, how to use the reference angle to show that. Now let's use a radian. First quadrant, still the reference angle. That means this part we have 0 to pi over 2. So for second quadrant, since 180 equals pi, I can write down theta equals pi minus the reference angle. For third quadrant, I can write down pi plus reference angle. For fourth quadrant, I can write down 2 pi minus the reference angle. You can do the calculation to figure out all the angles in quadrant 2, 3, 4 in radian. But there is a shortcut for special angle, pi over 3, pi over 4, and pi over 6. That's count as pi over n. So if pi over 3, pi over 4, pi over 6 as reference angle, then the second quadrant angle will be n minus 1 over n pi. For example, for pi over 3, when n equals 3, the second quadrant angle will be 2 pi over 3. When n equals 4, n minus 4 means 4 minus 1, that's 3 pi over 4. When n equals 6 means 5 pi over 6. For third quadrant angle, we can write down n plus 1 pi over n. In other words, when n equals 3, then n plus 1 will be 4 pi over 3. When n equals 4, you will get 5 pi over 4. If n equals 6, you will get 7 pi over 6. For fourth quadrant, the angle will be 2n minus 1 pi over n. For example, if n equals 3, then 2 times 3 minus 1, that will be 5 pi over 3. If n equals 4, you do 2 times 4 minus 1, that will be 7 pi over 4. And if n equals 6, you will do 2 times 6 minus 1, that's 11 pi over 6. So now you can check that line for the same color. Then you can write down all angles for different quadrants in radian. So for this red one, we have second quadrant, that's n minus 1 pi over n, which means 5 pi over 6. For third quadrant, it's n plus 1 pi over n, that means 7 pi over 6. For fourth quadrant, you will get 2 times 6 minus 1, that's 11 pi over 6. Let's go to green 1. So that's reference angle means pi over 4. Therefore, for second quadrant, we got 3 pi over 4. For third quadrant, we got 5 pi over 4. The fourth quadrant, we got 7 pi over 4. Let's go to blue line. Reference angle will be pi over 3. Therefore, we got 2 pi over 3 for second quadrant. Got 4 pi over 3 for third quadrant. And 5 pi over 3 for the fourth quadrant. Now let's work on the coordinates for each point. First of all, we already figured out here for a unit circle, the coordinate will be cosine theta, sine theta. Let's discuss the coordinates for each quadrant. We already know that for a unit circle, the coordinates is cosine theta, sine theta. Let's add one more, tangent theta. That's x, y, and then over here will be y over x. Because tangent theta equals sine over cosine. So let's talk about these quadrants, first, second, third, and then the fourth. We already know this will be positive x, negative x, positive y, negative y. So for first quadrant, we got positive x, positive y. Second quadrant is negative x, positive y. For third quadrant, that's a negative x, negative y. Fourth quadrant will be positive x, negative y. We can label for unit circle that each point coordinate will be CST, means cosine, sine, tangent. So let's label as CST. First of all, we will work on that sine for tangent this time. So for third coordinate, it's y over x. Use y over x, we can decide the sine for tangent. So y over x still positive. Y over x, this will be negative. And negative y over negative x will be positive. Negative y over positive x will be negative. So we label as a CST, 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 CST. Let's analyze the sine for each trig function for different quadrant. Look at the first quadrant. Cosine, sine, tangent, all positive. So I will write down all here. Look at the second quadrant. Cosine negative and tangent negative, but only sine is positive. So I write down S for second quadrant. For third quadrant, you could see that only tangent is positive, so I write down T. For fourth quadrant, cosine is positive, so I write down C. People make a sentence to remember this. All students take calculus calculus to remember for each quadrant which trig function is a positive. Now go back here. We know the coordinates will be CST. And all students take calculus. So for first quadrant, all positive, I will write down for cosine 0 equals 1. Sine 0 is 0. Then tangent is 0. For 30, we got square root of 3 over 2, 1 over 2. Then square root of 3 over 3. For 45 degree, we got square root of 2 over 2, square root of 2 over 2, and 1. For 60 degree, we got 1 over 2, square root of 3 over 2, and square root of 3. Remember that's a CST. That's the coordinates for each point on the unit circle. For 90 degree, we got 0, 1, and undefined. Now let's write down for the coordinates for each angle in different quadrant. If it's the red line, that means whose reference angle will be 30. In other words, their coordinates will be almost the same as 30 degree. That's square root of 3 over 2, 1/2, and a square root of 3 over 3. Then you can analyze for each quadrant which trig function is positive. Then the other two must be negative. For example, for the second quadrant, we know sine is a positive, means cosine and tangent are negative. Now I finish labeling the coordinates for each point according to their reference angle. Then I decide the sign for CST. Look at the second quadrant first. We know that only sine is positive, means middle one is positive. The other two coordinates will be negative. Therefore, I put the negative sign for first and then the third coordinates. Negative 0, still 0. For third quadrant, tangent is positive. Therefore, means the third coordinate is positive. Then the first two coordinates must be negative. Therefore, I put the negative, negative. Yeah, negative. Negative 0, still 0. Then I have negative 1. Then for the fourth quadrant, means cosine is positive. According to CST, means the first coordinate is positive. The other two must be negative. So put the negative, 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 negative. We know negative 0, still 0. So we don't put that negative 0 there. And also over here, that's a 0. So we already finished constructing a unit circle. And remember that coordinates for the unit circle are CST, means cosine, sine, tangent. And each trig function has a different sign for different quadrants. We use all students take calculus to remember that. That means for second quadrant, only sine is a positive, cosine and a tangent will be negative. For third quadrant, tangent is a positive, which means you will have a negative cosine and a negative sine. For fourth quadrant, only cosine is a positive, means your sine and a tangent will be negative.